Okay, so this is angles, coterminal angles in radian measure. We went over this yesterday in class. I know some of you were on a field trip or you missed because of quarantine. So we're spending today looking at angles. Now you know that one complete rotation is 360 degrees, okay? All right, this side of our angle where you start, that's called the initial side. And then where your angle ends is called the terminal side. So let's say my angle comes over here, and then this would be the terminal side of the angle. Okay, you can have more than one rotation, so you can have angles that are bigger than 360 degrees. You just show that by going all the way around the circle and then continuing. With one rotation being 360 degrees, straight up, or kind of like due north, would be 90, 180, 270, and then 360. Okay, the other thing keep in mind is what your quadrants are. So this is your first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, so let's sketch some angles. So first 240 degrees. These do not have to be perfect. They are a sketch, okay, so you don't need your protractor. Really the main thing is to make sure that you get in the correct quadrant, and then, try to estimate about where that angle would be. Okay, so 240 degree angle. Well, this is 180, so you know you're going to be past 180. So start here at 0, 90, 180, 270. Okay, so obviously 270 is too far. So this 240 degree angle is going to be in between 180 and 270. So I'm going to estimate that it's about right there, 240 degree angle. Okay, 28, a 500 degree angle. All right, so this is going to be more than one rotation because 500 is greater than 360 degrees. So you show one complete rotation, so that's 360 degrees. If I go to here, that's another 90 degrees. So far we've gone 360 plus 90, which would be 450 degrees. Okay, so now I need a little bit more. I actually need 50 more degrees. So if I add 50 more degrees, that'll give me that 500. Well, 50 degrees, part about halfway through the next quadrant, and that's going to give you that extra 50 degrees. So in total, this whole angle is 500. Okay, you can also have negative angle measure. So positive angles that we've been talking about go counterclockwise. Negative angles go clockwise. So if I go clockwise around, so one rotation clockwise would give you a negative 360 degrees. Okay, so here would be a negative 90, this would be negative 180, and negative 270. So for a negative 50 degree angle, that's going to put us in the fourth quadrant, about like this, and negative 50 degrees. Okay, so then for a negative 220, same thing. Okay, so we're going to go clockwise on this one, so 0 degrees. Halfway around is going to be a negative 180. So negative 220, go a little farther than that. And here's a negative 220 degree angle. Okay, coterminal angles, co meaning more than one, terminal where it stops. Okay, so you can have multiple angles that stop in the same place. Now, they're not the same angle measure, okay, but they stop in the same place. And to find those, you are going to either add or subtract 360 degrees, and that will find you other coterminal angles. Okay, I'll show you what I mean. So here, okay, let's think about 65 degrees. So if I have a 65 degree angle, it's going to be about right here, 65 degrees. Okay, so when I'm looking for a coterminal angle, I'm looking for another angle that's going to stop in the same place. Okay, so there's a couple of ways you can do that. I could do that by doing one complete rotation of 360 degrees and then do an extra 65 degrees, and that would give me an angle that stops in the same place as that 65 degree angle. So what I did was I added a rotation. So 65 degrees plus 360 degrees, okay, adding that extra rotation is going to give you a 425 degree angle. So there is a positive coterminal angle. Now we could keep adding rotations and just keep adding 360 degrees, and that would give you other angles that are coterminal with 65 degrees. Okay, now here's your other option, is you can go clockwise and have a negative angle measure. So if we did that, start at 0, and if I go clockwise around, I can still stop in the same place as that 65 degree angle, but I've done it clockwise, so it's a negative angle measure. So I've gone all the way around my circle, except for the last 65 degrees. So you could go 65 minus 360, and that would give you a negative 295 degree angle. So that would be another coterminal angle. And again, you can keep subtracting 360 degrees to add on more rotations going clockwise. Okay, so let's go to 230. Now you don't have to draw these. I'm just drawing it to try to give you, so you can kind of see what I mean here. So 230 degrees would be past 180, but not to 270 yet. So here would be 230 degree angle. Okay, so another positive coterminal angle would be, I could do one complete rotation and then go around again and stop where that angle stops. So that would be 230 plus 360, so that would be a 590 degree angle. Okay, similarly, if you start at 0, but you go clockwise, instead, we're going to have a negative angle measure. Okay, so this would be 230 minus 360 will give you a negative 130 degree angle. Okay, so then for 33, same thing. So 300, you can add 360, so that would give you 660. 300 minus 360 would give you a negative 60, so that gives you one positive and one negative coterminal angle. Okay, 740, if we add 360, that's going to take us to 1100. Okay, so there's a positive coterminal angle. If I'm looking for a negative coterminal angle, then I need to subtract. Okay, here though, when you subtract, you have another positive angle. Okay, so if we take that 380, subtract 360 again, we get 20 degrees. So that's still another positive coterminal angle. Then 20 degrees minus 360 one more time gives you a negative 340. Okay, so there's a negative coterminal angle, and then these are all positive coterminals. Okay, they are all coterminal angles, just in the directions I asked you for one positive and one negative. So if you don't get a negative by subtracting 360, you need to keep subtracting rotations of 360 until you get to a negative angle measure. So this 740 degree angle had multiple rotations in it. So there's 360, another time around is 720, and so since you want 740, I got to go a little bit farther. Okay, so that's why we had to subtract 360 so many times, because of the multiple rotations. Okay, let's talk about radians and degrees. So you can convert from radians to degrees. Your your circle, okay, if we go around, of course you know that it is one rotation is 360 degrees. Okay. In radians, one rotation is 2 pi radians. So there's 360. But one rotation is 2 pi radians, which means pi radians would be at 180, 1/2 pi, or pi over 2, would be at 90, and 3 pi over 2 would be at 270. Okay, so if you think about this, you start at 0, and if 180 is pi, then halfway at 90 degrees is pi over 2. Okay, and then if 180 is pi and you finish that rotation as 2 pi, halfway between 1 pi and 2 pi is 1/2 pi, or 3 pi over 2. Okay, now you can pretty easily convert back and forth. So if you want to go from radians to degrees, you multiply by 180 over pi. If you want to convert from degrees to radians, you multiply by the reciprocal, so pi over 180. So I'll show you. So 135, we want to change it to radians, so I'm going to multiply by pi over 180. This is over 1. Okay, so then I can just reduce. I can take out a 45, that's a 3, this is a 4, 3 pi over 4. Okay, if I want to go from radians to degrees, then I multiply by pi over, oops, nope, I did that wrong. Multiply by 180 over pi. So then here, my pi's are going to cancel. 4 can go to 1 and takes this to 45. So what you're left with is 5 times 45 on top, 1 on bottom. This becomes a 135 degree angle. Okay, so that's converting from radians to degrees or degrees to radians. All right, we are going to stop there today because that is all we have time for.